Hey everyone, in this video, I'm going to show you how to build a CRUD to-do list application using Python and FastAPI and host it on the AWS cloud. CRUD stands for Create, Read, Update, and Delete. And practically every type of app will need to do these operations with its data, whether that's posting a tweet or uploading an image. So building a CRUD application is an excellent first step towards building something much bigger. A to-do list app is a great example of a simple CRUD app. We can create new tasks, edit them, mark them as done, and delete them. Let's take a look at the architecture. We're going to build this as a backend REST API using FastAPI as our framework. All of this will be running on the cloud on AWS. We'll deploy our function on AWS Lambda, and the data will be saved into a serverless database, DynamoDB. And the data model is pretty simple. It's a to-do list, so we'll just have things like a task ID, a user ID, the content and status of a task, and then the timestamp for when it was created. We'll also create some REST endpoints so that our CRUD operations can be used by anything with an internet connection, such as a web app. We'll build the cloud infrastructure first using AWS CDK. Then we'll write out the Python FastAPI application and deploy it. We'll also write integration tests using the PyTest framework to see if our endpoints are actually working. And although we won't build the front-end web app as part of this tutorial, I've also included the source code for it in case you wanted to have a look for yourself. Now let's take a closer look at what we'll have by the end of this tutorial. We'll be able to add tasks. We'll also be able to tick tasks off our list. We'll also be able to delete tasks. And the tasks are bound to the users, so if we refresh the page, we should still see all the tasks that we edited earlier be loaded from the backend database. And if we change to a different user, so from here I change from Pixagami to Jack, then the tasks are not saved for this user, so we only see the tasks for the user we're logged in as, and each user can create their own set of tasks. The focus of today's tutorial is to build this backend of this app, so the FastAPI application in Python, and we're going to have several endpoints to create, update, get, and delete tasks. This FastAPI is going to be hosted on AWS Lambda functions. So when we use the API, it's going to charge us only for the amount of compute we use, and it's going to be very cheap to run, or probably free for most of the time. And all the data is going to be saved into a serverless database. We're also going to use AWS DynamoDB for that, so all of our information will be stored in the cloud. So this API effectively turns our app into an online application. The front end, I'm going to also include this in my source code. So if you go to the GitHub project link in the comments below, you'll be able to see all the front end source code in the to-do site folder. But it's not a focus of this tutorial, so we're not going to build the front end ourselves, but I just wanted to put this here to show you how you could use this API with the front end once you have it built. So with that out of the way, let's get started with our project. For the very first step of this project, I want to create all of our AWS resources that we will need for this application. So that includes the database table, DynamoDB, to store all of our to-do list items, and also AWS Lambda, where we will host our FastAPI Python application. And then we'll have to connect these two together and make them accessible via a URL. But rather than clicking it here to do it manually in the console, we're going to manage all of this using AWS CDK, which is a toolkit for managing all of this stuff with TypeScript code. So before you start this section, please make sure that you've set up an AWS account, you have the AWS CLI configured on your computer, and you also have AWS CDK. If you don't have those things yet, then please look in the comments section for where you can learn about them. So now I'm in my project directory, which I've called to-do list. And I've created this directory because even though right now we're building the infrastructure, we'll eventually need to build the API and the front end as well. And I want to put them in separate folders, but under the same project. So I've created this sort of master project directory, and then now I'm going to create the infrastructure directory specifically. And I'm going to call it to-do infra. I'm going to go into the folder and I'm going to initialize my CDK project. And I'm going to be using the TypeScript language, but you can also use any of the other languages if you're more comfortable. Now that can take a little while, but once it's done, let's open this up in our Visual Studio Code editor. So here I'm in my to-do list project and I have my to-do infra right here. And let's take a look at the project. There's two files that we care about, the to-do infra ts, which is the name of the stack that we're going to deploy. So this is going to be a CloudFormation stack, which is sort of like a grouping of AWS resources that are supposed to work together. We can ignore all of these things for the moment if we've already set up our account and our region in the CLI. So we don't need to do anything because when we use CDK from the terminal, it will respect whatever configuration we've set up for our AWS CLI account. The other file we care about is this to-do infrastruct.ts. This is where we're going to be writing all of our AWS resources. So you can see the example here. It's the SQS, which is a queue resource, but that's just an example. So we can just go ahead and delete that. So let's start off by creating our table. We first have to import the DynamoDB library from CDK. So we'll do that by typing import star as DynamoDB from AWS CDK lib / AWS DynamoDB. And then we can create our table like this. So I do table equals new DDB table. And then we call it task. So this is the task table. This is my to-do list table, and I'm going to call the to-do items a task. And then we'll have a partition key, which is the index column of the table. I'm going to call this task ID, which I'm going to make into a unique identifier, and it's going to be a string. And the billing mode is going to be pay per request because DynamoDB has two billing modes. It could be either provision-based, where you reserve a certain read and write capacity, or you can make it on demand, which they call it pay per request. So we only get billed every time we actually read and write items to the table. And I like this because it's a lot cheaper for learning because most of the time you aren't using it. So it doesn't make sense to constantly pay for a reserved capacity. Finally, because this is a testing table, I'm going to create something called a time to live attribute. This means that this is another column for my items, and DynamoDB expects this to be a Unix timestamp. And that timestamp is the date at which this item will get deleted from the table. Whenever I add an item to the table, I'll get the current timestamp and add 24 hours to it, so that DynamoDB deletes all my to-do items after 24 hours. And that's because when I'm testing something like this, or when I'm testing a bigger app, I don't want to fill up my table with a lot of junk and test data. So that's why I'm creating something that will automatically be cleaned up after a while, once I know that it's either working or it's not working. In a production table, you might not need this because you might want your data to live forever. The next thing I'm adding to the table is called a global secondary index. So from here, I do table.add global secondary index, and these are the parameters. The index name is going to be called user index, the partition key is going to be called user ID, and the sort key is going to be created time. That's going to be a Unix timestamp as well, and we're going to store that as a number. So what is a global secondary index? Well, if you know what SQL tables are, you can almost think of this as a separate table in your database. So this would be one table with the task ID, and this would be another table called users, and then they would have a join between them. But DynamoDB tables are, they don't have separate tables or inter-table connectivity or any kind of join type of queries. So instead, we decide to use the same table, but tell it that we're going to use this other column as an index as well, because we might want to search this column. And the whole purpose of this is so that we can look up task or to-do items by user, because we're not just storing tasks for one user, remember? Every user for our task application will be a different person. So we don't want to just load all the tasks. If I'm looking at the app, I just want to load my task. So I need a way to look up all the tasks that belong to me. And it makes sense to look them up in the order that they were created, or the reverse order, so most recent first. So this is basically saying that I want a fast way to find items by looking up user IDs, and I want them to be ranked in order of the create time. And this could be either ascending or descending. That's okay. DynamoDB will pre-index this so that our query operations are faster without us having to sort of go through the whole table. The most challenging part of creating a database for our application is modeling the data structure. And if you model it successfully, then all the lookups should be fast or constant time, which means I don't have to scan through items and filter them. Any table that grows linearly with its input size is going to not scale very well. So that's why we have this global secondary index. And if you're confused by this right now, don't worry, because we're going to see how to use it later on. Now we have the table and it looks pretty good. The next thing I want to do is create the Lambda function. It's going to be where I host my Python FastAPI application. But I don't actually have my Python API script yet. So let's create a stub or a placeholder for that first, just so that we can go ahead and use it to create this infrastructure. And then we'll go back to fill in the gaps later on. So remember at the beginning, I wanted each major part of the project to have its own folder so it's easier to organize. I think the API is big enough to have its own scope. So I'm going to create a folder for it called API. In this folder, I'm going to create a file called todo.py, which is going to be my Python FastAPI script. I'm not going to implement this yet, but I do need a handler function stub for Lambda to use. So I'm going to create one here and I'm going to call it handler. It has event and context. And this doesn't need to do anything. It can just return something like this, hello world. There we go. So very simple Lambda handler, but it's enough for us to move on with the infrastructure and get this hosted. So back to our infrastructure stack, let's import Lambda to our file here. Import star as Lambda from AWS CDK lib AWS Lambda. Now let's write the code to create our Lambda function. New Lambda function, and then this, which is the parent scope of this resource, which is going to be this CDK stack we have here. API, which is just the local identifier of this function. It doesn't have to be globally unique because this will get prefixes and suffixes to the name later. And then the meaty part, which is all the Lambda props or the properties that I want to create this function with. I'm choosing Python 3.8, which is the latest Python runtime for this function. So that's what the function is going to run on. And then the code is where my actual function code lives locally as I build this file, because it needs to upload that to Lambda. So in this case, it's 2 dots and then /API. So that's because that when I build the infrastructure code, I'm building it from this folder to do infra, but the API folder is above it. So it has to go back one directory and then to the API infra. And by doing this, I will upload the whole folder to AWS Lambda. The handler is telling Lambda which function it should run when it is invoked or when it is executed. Because we uploaded the entire API folder, we're going to have a file called todo in that Lambda scope, and todo will have a function called handler, which is why in our handler we have todo.handler. It needs to know the file name, and in that file it needs to know the function name. Finally, we have the environment, which is, for this one, these are the environment variables. These are the global variables that we pass to Lambda that it will have access to. And we need this because Lambda will need to know which table it needs to edit. So this Lambda function is going to handle all of our API calls, task updates, creating a new task, editing a task, deleting a task. But to do that, it needs to know which table to write the data to. So I have to give it the table name. Finally, we have the environment variable, which is the table name of this table, because remember, our Lambda API will eventually need to know where to write this data to. And the best way to do that, I found, is just to give it the table name in the environment variable. From there, Lambda can connect to this database table and then write, update, or delete any of the items it needs. To get the table name from this table, we've actually stored a reference to this resource already that we've created, and we could just do table.tablename. That gives us the name. So that gives us our Lambda function, but we still don't have a way to execute it. When we create this Lambda function on its own, it's just going to sit in our AWS account, and the only thing that we can use it through is our console or our AWS account SDK directly. But I want to make this an app with a front end, and if I want something else outside of AWS to access this Lambda function, I will need a public endpoint for it. Luckily, Lambda gives us a very easy way to do that. This used to be really difficult, where you have to hook it up with something called API Gateway, and that's quite hard. But now there's a much easier way, and we could just use Lambda's function URL. And this is how we can create a function URL. So we reference our Lambda object, which I've called API here. So do api.addFunction URL, and then provide it these parameters. We don't need any authentication for this. This is a relatively lightweight API, so I'm just going to put auth type none. I also recommend adding this CORS object here with allowed origins to star, allowed methods to all, and allowed headers to star. If you don't know what CORS is, it stands for cross-origin resource sharing. If you don't configure it properly, then it will prevent certain browsers from being able to use this API if it's hosted on a different domain to where the API is hosted. So we just add that there because we'll build a front end that we want to test from localhost. And if we don't have this, then the browser won't be able to use this URL. To make CDK print out this URL to the console when we deploy this, I'm also going to add an output resource. This is going to be CFN output, and I'll have to import that as well. We can just import that from AWS CDK lib up here, and that will print out the API URL, which is going to be the function URL we can call here. And then we'll be able to just click that or use that in a web page and have it use this function remotely. Finally, one last but important step is to grant our Lambda function access to this table. So by default, AWS resources are quite secure. And even though we created these things in the same account and on the same stack, they don't automatically have permission to access each other. So this Lambda function cannot read or write from this table by default. We have to explicitly give it the permission to do that. So let's do that here. And this is really easy to do. All we have to do is just write table.grant read write data to the Lambda function, which is called the API. With that finishing touch, our CDK application should now be ready to deploy. So let's just summarize what we have here. We've got a DynamoDB table where we're going to store all our task data, and we're going to index them by the task ID, which is going to be a unique ID. We're going to also expire the resources after a certain time, which is going to be a Unix timestamp that we write under this column here. We're going to add a global secondary index so that we can actually look up tasks by the user as well, which also means that every task we add to the table will need to have task ID and user ID and a create time for all these three things to work. We created a Lambda function from a placeholder Python file that we have here right now. And this is going to be where we host our FastAPI eventually. So this is how we host the function and for it to run in the cloud. And it's going to know how to talk to the table because we gave it the table name in the environment variable. We made a function URL so that we can click on this like a web URL and then use this function from anywhere we want. And finally, we give the API or the Lambda function the permission to read and write data from the table. To deploy this application, go back to your terminal and type CDK deploy. It could take a while, but once deployment is done, we get our stack output here, which is the API URL I said earlier. And here it's just a really long URL, but we can actually click on this and invoke our Python function. So let me click on this there. And it actually works. Even though the JSON says syntax error, if you go to raw data, you can see our hello world text is actually printed out there. So that's looking pretty good. If we go back to our AWS account as well on our console, we should also see those resources. The stack is created in something called CloudFormation. So if you find CloudFormation in your dashboard and click on it, you should be able to see the stack we just created in your CloudFormation page. And if you click on the stack itself, you get taken to this page where you can see more information about it, such as all the resources it created. And you can see here, it did create this function. It has this URL. And it's also got the table here. So we can actually also look at the table and the function just to make sure that they've been created properly. Here's my table in the DynamoDB console. I've got my task ID here and there's no items yet, but that's okay because I just created it. List items and then run this. There'll be no items, but that's fine. Similarly, I can see the Lambda function has been created here as well. And if I go down, I see the code that I've written in the Lambda function here. So this handler event context return status code. Our infrastructure has now deployed successfully, and we've completed the CDK infrastructure part of this project. Next, let's move on to actually writing out this API code, this Python handler, to read and write tasks from our table. So now that our infrastructure has been deployed and is confirmed to work, let's actually write out the to-do code of our FastAPI application. Remember, when we created our Lambda function, we pointed the handler to this file, todo.handler here. And we created a placeholder for that with just the empty return status code hello world. We're going to fill this out with the actual FastAPI application code, and we're going to let Lambda host this so that we can call it with our endpoint. Now, I'm going to go pretty quickly through this. So if you're not familiar with FastAPI or Lambda, then I recommend you check out the video in the description in the top or check the comments because I do have a video that covers this topic in more detail. So let's get started. First, I'm just going to delete my existing handler code. I won't need this anymore. And then I'm going to import FastAPI. I'll create my FastAPI app, and then I'll create the index route. And I'm gonna say hello world from to-do API. Now from FastAPI's perspective, it will route the root endpoint over to this message here, and that's fine. But Lambda doesn't understand this yet, because remember here, we told it to use this handler function as its handler. So we actually have to wrap this FastAPI in a handler function, which we can do by importing the mangum library. And I'll just create a new handle object here, which is just a mangum wrapper over the FastAPI app. That is the bridge that will make Lambda here be able to understand FastAPI's interface. Now, this is all the code I need, but if I deploy this to Lambda, if I run CDK deploy again, it's not going to work because it's just going to deploy this todo.py file, which is in my API folder, but it won't actually have the FastAPI or the mangum dependencies that we installed, which is somewhere else in our system. So before we can actually just test this simple message, we have to find a way to also bundle these dependencies with our Lambda code. Now there's many ways to achieve this, but I think one of the simplest ways to do that is to create a bash script or a shell script. It might be different if you're on a Windows, but I'm on a Linux system. It should be the same for Mac. We're going to create a shell script that when we run it, it installs these FastAPI dependencies into a local folder. So I'm going to install these locally, and then I'm going to zip up that folder and put this to-do file into that folder, into that zip. And then I'll upload the whole zip to Lambda, so it will have these dependencies. So I'm going to create a helper script to do that. And I'm going to call it package for Lambda. And here's what my script is going to look like. So let's talk through the commands. First of all, I set this line, which will make the whole script fail if any one of these lines fail. Otherwise, it might just fail on one line and continue executing. The next one, I use pip, assuming you have pip installed on your system already. I use pip to install all the files in my requirements text, which I actually haven't written yet, but I will write. It will install them into a local folder called lib. So if I run it here, it will install it here under API. And then I'm going to cd into lib, so go into that directory, zip it up as this Lambda function file here, as this Lambda function zip. And then I'm going to add my todo.py, this one here, into that zip. And then I'm going to clean up that lib file that I created, so I only have that zip file left. First of all, let's create this requirements text. This is just a text file that has our dependencies we want to install. And this one's pretty easy. We'll just have FastAPI and mangum that we had earlier. So now let's go into our API folder and run this command and see if it works. I'll clean this up first. Go to my API. So now I'm in my API directory. I need to make package for Lambda an executable file. So I'm going to change the permissions there. And now if I look at it again, it's highlighted differently, which means I can execute it directly. So I'm going to do that. Package for Lambda. Okay, and if you let that run successfully, you go back to your folder again, you should see that a Lambda function zip has been created. And if you navigate to the folder, you should see it here, and you should be able to open up and see all our Python dependencies and the todo.py file included there as well. So this is the whole thing that we're going to send over to Lambda. Now, if you are working in a Git directory, then I also recommend you to git ignore zip files because they can be quite large and you definitely don't need to commit them with the rest of your project. So make sure you ignore this. This isn't a Git directory right now, so I don't have my git ignore file here. To use the zip file, let's go back to our infrastructure stack. And instead of using the whole API folder as our code asset, we're just going to use the Lambda function as the code asset. Because if you look at the helper text here, it says it loads the function code from a local disk path, which could either be a directory or a zip file. So we're just going to specify the zip file directly. API/lambda function.zip. Now let's go ahead and deploy this and see if it works. So go back to your infrastructure folder and run CDK deploy. Once the deployment is finished, let's check our endpoint again and see if we're hitting our FastAPI route. And it appears to be working. So when we call the endpoint, the message is now hello world from to-do API. So back to my todo.py file, let's start writing the code that will turn this into a CRUD app. When I do projects like this, I usually like to start with a bird's eye view of the project and decide on what interfaces and endpoints I want to write. So I'll usually start by just sort of listing out all the different endpoints I want. And I have them here as comments. So here I want a route to create a task. So it's going to be a put request to create the task. That's going to create my to-do item. And this is going to be the function signature. And for that, I'm going to have to create a put task request. So like a data model for what a task looks like and what parameters are involved. I could do separate parameters, but I prefer to have a data model or a data object to group them together like this. Next, I'm going to have an endpoint to get a task, and I'm going to get it by specifying the task ID. The function signature is really simple, just get task and retrieve the one with the task ID. And that's my simple get operation. Then I also want a list task. So if I want to see the, for example, 10 most recent tasks by a certain user, I can use list task instead, and it'll sort them by the user and get the most recent ones. I also want to be able to update an existing task. So again, this method signature is quite similar. We'll use another put task request, and I'll use this to update a task that already exists in my database. And then finally, to complete our CRUD operation, we'll also need a delete task, which will also take a delete ID. So that's just a high-level summary of the different functions we'll be implementing. The first step to implement anything is to define what this data model is, this put task request. And in FastAPI, we can do that by using the Pedantic base model class. So I'll import base model from Pedantic, and here is going to be my data model. Put task requests, it's going to have a content, so that's going to be the description of my task or my to-do item. A user ID and a task ID, they're both optional because we don't always need to supply them with our task request. And then is done Boolean, whether or not this task has been completed. So we can show a tick box next to the task on our front end if we wanted to. I will also need to import this optional from typing, so I'll do that first. So the data model is ready. Let's now implement our first endpoint, which is to create a new task. Let's uncomment that and put in the code. So when creating a task, I'm going to group it under an item object like this, and it's going to have all the fields that I specified earlier here, and also that I specified in my table. So it's going to have user ID, create time, task ID. Let's just make sure it has all of those things. So user ID here, yes, we'll get that from put task request. So when we create a new task, we need a user ID. The content, we'll also get it from the request. All tasks are going to be created not being done. So is done is just going to be hard coded to false. The create time, I'm going to use the time library, which I still need to import, and get the current Unix timestamp. So that would be used to sort the task later on by creation date. And the task ID, I'm actually going to create one here because I'm creating a task. I want a new task ID. So I'm going to use the UUID library. Again, I can import this as well. And I'm going to use that to generate a unique string ID, which I'm going to prefix with task underscore and set that as my task ID. So all of these will be completely unique. And then for the time to live, I'm going to delete it 24 hours after I create it. So I have my created timestamp here, and then I'm going to add this number, which is 24 hours as seconds because Unix timestamp operate in seconds. So I'm going to add this many seconds, which will set a timestamp in the future that's exactly 24 hours ahead. And my table, when it sees this number, it's going to delete it at that time. So all these tasks I create are only lasting for 24 hours because I want it to be temporary. So that's my item. How do I actually get it into my table now? I actually have another video tutorial on this as well, where I show you how to interact with AWS DynamoDB from AWS Lambda. So if you want to learn how to do that, please check out the video in the comments or in the top right corner. Now, before we can access our DynamoDB table from here, I'm going to create a function to actually retrieve it and create a SDK client to talk to that. So this is what it's going to look like. So remember, we set the table name environment variable in our Lambda function, and we set it here. So this is how we can identify the table. I have to retrieve this from the environment variable from Python using os environ_get. Now I'll have to import this as well. So let's go ahead and do that, import os. And then I'll need to import the Python SDK, Boto3, and I can get a DynamoDB client like this. You can search Boto3 on Google for the documentation or the API guide if you don't know how to use it. But for now, we're not going to do that. We're just going to go ahead and import this. Now, we don't actually need to add Boto3 to our requirements because on AWS Lambda, it's actually one of the libraries that come default with the runtime. So we don't have to explicitly install this like we did with FastAPI and Mancom. So now I have a function to get my table client, and this should be able to give me access to the table. Let's go ahead and use it to add our item in there. And to put the item into the table is pretty easy. We get the table client that we created with our helper function here, and then we're just going to call table.putItem, and then item, capital I, equals item is the one we created here. So we're going to call this API, call this SDK to put this item into the table. And because it already has a task ID, it's going to use that as the primary key or the primary index. And then finally, we'll return the item as a task as well, so that if we call this API from the front end, we can get details about it. For instance, the task ID, which we might need later on to display it. So now this is done. Before I implement the rest, I might actually want to test this first just to make sure that my table connection is working properly. However, to deploy this, I can't just run CDK deploy because remember, we deploy the zip file now and not this file on its own anymore. So if I run CDK deploy now, it's going to deploy the zip, which obviously hasn't changed since we last packaged it. Instead, I'll have to go back to my API folder, and then I'll have to run that packaging script again to regenerate that zip file. And once I do that, I can go back to my infrastructure folder and then run CDK deploy. Once the deployment is done, let's check our endpoint again. So if we go to our API endpoint, it still works and we still see our hello world message because that's the root path. But if we go to /docs, we get to see the documentation and the create task is appearing here too. If we expand that, we can see the data schema that we defined, and we can click this button to try it out. So here I can actually edit the JSON object I'm posting in. I'm going to call this test task, then maybe XYZ. User ID, Scummy, then content. This is a test task. So let's go ahead and execute that and see if it actually shows up in our table. And here we can see the response. This is the curl command to call this endpoint the way we did. That's the request URL. And here's the response body. So we actually got the task returned to us. And even though we did supply a task ID to it, it ignores this completely because looking at function code, we don't really respect the task ID sent in the put task request because we want to create our own unique one here to guarantee that it is unique and it doesn't overwrite existing task. That's why when we see our return, it's actually this completely unique number. We also see the created time and the time to live has been added. And just to double check that, we can also go back to our DynamoDB table where we should see our task appear. So if you go back to your DynamoDB table and then find the table that you created and click Explore Table Items, you can find the task that you just created from your API here. So this shows that we did manage to write a task from our FastAPI all the way to our DynamoDB table. Now that create task is working and we tested it with our table, let's go ahead and implement the rest of these functions. Getting the item is really easy. We'll create a new table client and then we'll just call table.getItem. And then the syntax is key equals and then an object, which is our primary key. Key name is task ID as we've specified in our infrastructure. And the value is going to be whatever we pass to it from this get task route. And the item, if it exists, will be stored here in this item. If this item doesn't exist, this item is going to be none. So let's create error handling for that too. If the item is none or it's not found, then we can raise an HTTP exception, which status code 404, the universal one for item not found. And we can also write the details in there. Otherwise, we will return the item. And I'll also have to import this HTTP exception. So I can import it here, or I can actually also just import it from my FastAPI. So I'm going to do that. So that should be get task. And let's implement list task next. This one is slightly more involved than just getting the task because we have to query the table for a number of tasks. I mean, with the get task, it's pretty easy. If we know the task ID, we can get that value directly. But in this one, we want to get a certain number of tasks according to the user ID. So that's why we have this global secondary index. Remember, we added this earlier. It's another way to query our table quickly and efficiently. So we're going to need to query the user index of this table, and we're going to look for ones where the user ID matches a value that we specify. And that's what this query operation does. Table.query, and then we can specify the index name. So that's going to be the user index. And then we're going to say the key condition is key user ID equals user ID. By the way, we can import this as well. That's a DynamoDB helper function. So from boto3.dynamodb.conditions import key. That just saves us doing a bit of manual work. So key condition is where the user ID equals this one that we specify. Limit 10 is self-explanatory. We want 10 items. Scan index forward is kind of like what order do we want to get this information in. I think that forward order means ascending. So when we put items in by create time, scan index forward will give us the 10 earliest items created by this user. But I don't think we want that. I think we care about the latest items. So I'm going to put scan index forward equals false. And finally, if this response is successful, we'll be able to find the items in the items field of this object, which is, this is just DynamoDB convention. So this should be our list task function implemented. Next, we'll implement update task. So here is where we have an existing task, but we want to override some of its values. It's similar to the create task that we have earlier, except that we're not going to override the task ID. Instead, we're going to look for the item with this task ID and then update the rest of its values. For what it's worth though, we can actually implement update the same way we have create here. So just copy this code, except instead of this task ID, we'll just replace it with whatever is given to us in put task request. But there's some cases where you might not want to do that for whatever reason. So I'm going to show you here how to actually update an existing item. And the syntax for this, honestly, I find this a little bit complicated. I actually had to look this up in the documentation with the update expression and expression attributes value. It doesn't make a ton of sense to me, but that's just how we do it. So I recommend just writing this down first. And then if you really need to know how to edit it, then look up some documentation or just try to edit the syntax the way it is here. But just to summarize, we get the table like we do with all the other API calls, and then we call table.updateItem. We have to provide the key, of course, and then we can give it this update expression, which tells us how to update this item. And finally, for my actual API return, I'm just going to return the task ID that we sent to it. Our last API route is a really easy one, app delete. To implement this, you guessed it, we get our table client, and then we just call table delete item. And same as create item or get item, it's just passing the key of the task ID in, and then we can just return the fact that we deleted it. So now that's done, let's rezip and redeploy our package again. So now the stack has finished deploying, let's go back to our API and check out the docs again. So just go to your API and type /docs, and now we should see the rest of our API show up here. We created that task earlier under the username Pixagami. Let's see if our list task operation works. And I'm gonna click here, click try it out, and then for my user ID, I'm gonna put Pixagami. Then just execute that request. And here I can see that it works. There's only one task because I only created one, but I have this first test task I created and it's got my task ID. So now I'm gonna copy that task ID and try another API. Let's try the get task. So click try it out, and then I'm just gonna paste my task ID there and see if that one works. And that one works as well. It just returns the task that I put here before. Now let's check out update task. So let's update this task ID and change the done flag to true. So we're gonna go to this one, and then update task. Then we'll try it out. So the task ID is what I copied here. User ID, we'll keep it the same. Pixagami is done is gonna change to true. And then the content will go, this is an updated task. So let's go ahead and run that. Hopefully it works. Okay, so a 200 and it's been updated. And now let's get the task again, just to see that it is updated. We'll execute that. And now here's the task. The content has been updated and the done field has also been updated. So this works as well. Finally, let's test our last thing, which is to delete the task. So try it out and then put in my task ID and then execute. And it deletes it as well. And finally, to check that it's really been deleted, let's go back to our list task and try it again under Pixagami. And this time it returns empty. Okay, at this point, we actually implemented everything and we can test it using this built-in API docs here. So now our backend is pretty much built and we validated that it works. But as you can see, to test that it works, it took quite a bit of time, and I don't want to do this each time I make a change to make sure that things are working. So I think we should write some integration tests using PyTest framework, just so that we can do all of what we did just then in an automated way. So back to our project, I'm going to create a new folder and I'm going to call it test. And then in the folder, I'm going to create a file called API integration test. Now, if you haven't written a PyTest test before, I have another video on that as well, so check it out in the comments or in the description in the top right corner. Otherwise, I'm just going to go through this quite quickly because I don't want to turn this into a testing project. The first thing I want to do is to test that I can create and get the task. So I'm going to create that test here and I'm going to call it test can create and get task. And it's going to run both the create operation and then the get operation. To test it against my real endpoint, I'll also need to know the endpoint in this file. So we just go back to our CDK application and it's this API endpoint that we've been using. So just copy that and then paste that into this endpoint constant here at the top of our project. Every time I want to run the test, I want to create a new unique user so that my test doesn't get polluted. So I'm going to do that with a new user, and then I'm going to have a user ID, unique user ID each time I run this test, and do that import there. Likewise, I'll also want some random task content. So let's go ahead and do that too. And now I need a way to actually talk to this API and send this payload as a request. To do that, I'm going to use the request library, which you can install by doing pip install request. So if you don't have it already, just make sure you do that first, pip install request. And I already have it, so nothing happens there, but you should run that if you don't have it. So we'll go back here and we're going to use that. So I'm going to create a couple of helper functions to call that create API endpoint directly. And I'm going to call this one create task. It's going to take a user ID and a content string. It's going to turn it into a payload, and then I'm going to use request put and then endpoint and then my create task route, which I've defined in my to-do API here. So this create task route, and then the payload is just going to be this JSON payload here. So I can call that from my test. And I'll be maybe more specific and call this create response. Now I'll create a similar helper function to get the task. So this one we a request.get, and it will do the endpoint get task. This time it won't have a payload. It's, the task ID is supplied through the path directly because that's how we specified it in our FastAPI. So this will be our get task helper function. We're going to extract the task ID from this and run it into get task and make sure that our user ID and our task content is actually what we provided. So first of all, let's assert that the status code is 200 so that the function was called successfully. And then let's extract the task ID from this create response. And once we have the task ID, we can pass it on to get task. We also want to assert that the get response has a status code of 200. And finally, once we know that both of these requests are succeeding, let's actually compare the contents of the message. So our tests should just look like that. And let's go ahead and run it and see if it works. To run a Python test, we'll go over to the root directory. So I'm here, and I've got my Python test folder here. And all I have to do is just run PyTest. So it's found my one test in here in this API integration test, and it's run it and it's passed successfully. So I'm pretty happy that that is successful. Obviously, I want to test the behavior of all the other endpoints as well. So I'm just going to copy and paste some code that I prepared earlier to do that. And we can talk through it, but I won't walk through it. So if you want to know about this in more detail, then just go and check out the source code in the comments. So this was the one that we created together earlier. I can also test that we can list the tasks. So I'm going to create 3 tasks and then check that I can list the task for this user and get 3 in response. I can test that I can update a task by creating a new task and then updating it and then getting the content and see if the content has been updated. I can also test that I can delete a task by creating one, deleting it, and then making sure that when I get it again, I'm actually getting an error of 404. And then I have the corresponding helper functions as well. So those are all my tests. This would be 4 tests in total for all the API coverage of this endpoint. And now if I run that again, I should see 4 tests passing that fully covers my API. All of them passed, and this time, instead of having to go and update my API or test them manually, I can just run this test as part of an automated workflow to make sure that my API is still working or that new features work. And just to manually confirm, if we go back to our DynamoDB dashboard and then run the scan query again on the table, we should see that a whole bunch of automated users have been created in this table as well as we were testing it. So if you've made it this far in the tutorial, then your API application, your FastAPI backend is mostly complete. So let's review what we've done so far. We've deployed all the AWS resources through code with the CDK stack here. And then we've written our FastAPI application in Python with all the different routes, and it interacts with our DynamoDB table to save our data. And we've written a bunch of integration tests so that we can make sure that the API is working properly and that it continues to work every time we update it. And once our API is ready, we can hook it up with a front end like this. So this is a Next.js web app. And I've pointed it to the endpoint that we've created earlier. And now we can test it by adding tasks, updating them, and deleting them. And even if we refresh the page or go away and come back again to this page, it's going to load all the tasks and the state of the task that we saved, because this is saved online to a table. Now, as I mentioned at the start, I'm not going to go through how to actually build this front end, but the code is available in part of the project. So here's the Next.js web app. It's pretty simple. So if you really want to know how it works, then feel free to take a look, because the code will be available in the GitHub project as well. And it's going to be in this front end folder here. So again, if you want to know more about how to build the front end, then feel free to take a look at the code or drop a comment if you want a tutorial on how to hook up a front end Next.js app with an API endpoint like this. Otherwise, that's pretty much it for the tutorial. I hope it was useful, and thank you for watching.